Welcome to the 6th lecture on module 1 on the course on ocean structures and materials, which is conducted under the braces of NPTEL IIT Madras. In the last lectures we discussed about different kinds of offshore platforms, some of them of a fixed type, compliant type, etc. In this lecture we will discuss something on subsea production systems. This is also an important component in different kinds of offshore structures. When we start designing offshore structures, we should have a fundamental idea about different types of subsea production systems. So, this lecture will focus on different types of subsea production systems, what are they, what are the different terminologies in subsea production systems, how do we understand them, etc. Subsea systems briefly is called as SSS. Subsea systems actually are multi-component seafloor systems. The moment I say multi-component, one would like to know what are the different components present in a seafloor system. Essentially, let us look at the function of a subsea system. They actually allow production of hydrocarbons in water depths where conventional fixed or bottom founded platforms cannot be installed. As we understand, ladies and gentlemen, all platforms, all types of platforms cannot be installed in all water depths. They have serious limitations with respect to the type of geometric form of the structure, different types of water depths, etc. So, if you have a location where the conventional fixed or bottom founded platforms cannot be installed, then one can go for subsea systems. Subsea system, as I said, is a multi-component seafloor system. They have different components as listed below. It contains array of subsea wells, manifolds, central umbilicals, flow lines, and a subsea system can be located many miles away in the deeper water, and then they can be tied back to the existing host facilities. Now, the host facilities which actually tie down back these subsea systems which are located many miles away in deeper water can be a floating production storage system. There may be FPS, there can be FPSO as we discussed in the last lecture. So, you can have an FPS installed at a distance which can be used to tie down the subsea systems which are otherwise deployed in deeper waters. So, ladies and gentlemen, in nutshell, subsea systems are actually multi-component seafloor systems used for offshore production of hydrocarbon in water depths where conventional fixed platforms cannot be installed. Let us look at quickly different layouts of subsea systems. As you see here in the picture, there can be different kinds of layouts. A single layout where I have got a well which can be connected to the host is a single. Can have a multi well satellite. There can be 3 different wells or n number of wells, all can be connected to the host. The host, as I said, can be an FPS. We can also have what we call cluster well system. So, wells can be clustered together depending upon the seismoprofile of yield of these wells. So, they can be clustered and then they can be connected to a single host as you see in the picture, or it can be a template structure where you got a template of series of wells connected in one group which can be further connected to the host, or obviously can have a combination of all these above. So, subsea systems have essentially 4 different types of layout. As you see here, single well satellite, multi well satellite, cluster well satellite, or a template system. Let us quickly look at each component of a subsea system in detail. As I said, it is a multi-component system, contains subsea production tree, pipeline and flow line, subsea manifold, umbilical, host facility, termination unit and production risers. So, you can also have components of template and jumpers attached to it as you see in this slide. So, subsea system contains various components as listed here: subsea production tree, pipeline and flow line, subsea manifold, umbilical, hose facility, termination units, production risers, templates and jumpers. Let us now quickly see each one of them separately in detail. So, the picture what you see here is a picture of subsea production tree. Subsea production tree is an arrangement of valves, pipes, fittings and connections placed on the top of a wellbore. So, you can see it is nothing but an assembly of different appurtenances put together, which will be arrangement of valves, pipes, fittings and connections placed on the top of the wellbore. Orientation of these valves, which you put as a connection in a subsea production tree, can be in the vertical bore or the horizontal outlet of a tree. Now, the layout of arrangement of the valves can be on the vertical bore or it can be on the horizontal outlet of the tree. Valves can be operated either by electrical or by hydraulic signals. Sometimes can also operate them manually by a diver, or occasionally can use what we call remotely operated vehicles to operate these valves. They are called ROV. The picture what you see here shows you the difference between a vertical bore and an horizontal bore. The arrangement of valves, as I just now said, in the production tree dictates the type of the tree. It can be either a vertical bore or an horizontal one. The picture what you see here is a conventional tree which contains a tree cap on the top, then the master valve block which is shown in the blue color here, connected to the tree connector through a tubing hanger which is connected ultimately to the wellhead. Similarly, in case of an horizontal tree, you have the tree cap not on the top as a cap, but adjacent on the sides. You can see here horizontal tree is more laterally spread than that of a conventional vertical tree. That is why this tree is called horizontal, whereas this is otherwise called vertical tree. So, it is spread horizontally or laterally, where it has got a tree cap connected to the wellhead through a tree connector, and the tree head is here, and the tubing hanger and the crown plugs are as similar to what you see in a conventional tree. So, the dimensions of a horizontal tree can be more compact in height compared to that of a vertical tree or a conventional tree, but it needs more lateral space circumferentially to house this tree in your production systems. The next component of a subsea system can be either a pipeline or a flow line. Let us try to understand fundamentally what is the difference between pipeline and a flow line. Pipelines and flow lines essentially are pipes or conduits. They are used to transport the fluid from one location to another location. Pipelines are actually piping, risers and appurtenances which are used in the production unit. They are installed for the purpose of transporting oil, gas, sulfur and produced waters between two separate facilities. The length and size of the pipeline or the flow line depends on its purpose. For the purpose of subsea production system, the pipe length can vary as short as 1 meter to as long as 100 kilometers. Longer the pipelines, typically they will have larger the diameter, up to about 450 millimeter in diameter. Then what are flow lines? Flow lines are actually piping system again installed within the confines of the platform or the manifold, whereas pipelines are installed for the purpose of transporting oil, gas, sulfur between two separate facilities. If you use it within the confines of the platform, I call that as a flow line. It is installed for the purpose of mixing the subsea manifold or routing into the process equipment. So, flow lines and pipelines essentially are systems which are used to transport fluid from one location to another location. If they are spread in a larger area and length, I call them as pipelines. If they are confined within the premises of the platform or the manifold, I call them as flow lines. This is a picture which shows you a typical subsea manifold as you see here. The manifold are connected to 12 inches flow line lay down sled here in the side, as well as the different umbilical cables which have been connecting the flow line lay down to the subsea manifold. As I said, if it is localized, it is a flow line. If it is spread wide for longer lengths, it may be a pipeline. Let us talk about another important component of a subsea system, which is subsea manifold. What is a subsea manifold? It is actually a gravity based seafloor structure. The moment I say gravity based, you must realize that this rests on the seabed by its self weight. It does not require any anchoring device to hold it down to the seabed. So, it is a gravity based seafloor structure that consists of an arrangement of valves, pipes and fittings. It serves as a central gathering point for production from the subsea wells. It redirects the combined flow to the host facility. Subsea manifold may not be needed for subsea designs in certain cases. I can give an example. When you talk about developments where individual production trees are directly tied to the host facility, you may not require a subsea manifold at all. A manifold arrangement can be of any shape, but normally it is either rectangular or circular. Maybe either a standalone structure or integrated into a well template itself, that is a possibility of a subsea manifold design. The manifold may be anchored to the sea floor with piles or skirts that penetrate the mud line only to improve the lateral stability of the manifolds. Size of a manifold is dictated by the number of wells it is catering to. Also, the pattern how the subsea wells are integrated into the system. The likely range of dimensions of a subsea manifold would be 24 meter if you talk about a circular pattern of design, and the vertical height can be as high as 9 meters above the seafloor. Let us talk about another component, which is umbilical. It is a bundled arrangement of tubing, piping, electrical conductors in an armored sheath. Armored means protected, armored sheath which is installed from the host facility to the subsea production system equipment. Remember, umbilicals are maybe pipes, maybe tubes, maybe conductors which are well protected. You may wonder why an umbilical should be well protected, because this is a tubing or a piping which connects the host facility. The host facility can be an FPS which is connecting the host facility to the subsea production system equipments. So, you have to protect these umbilicals from the lateral environmental loads to which they are subjected to. So, you need a proper sheathing to protect these tubes or pipings, because there can be reported accidents where the umbilicals have been subjected to severe forces. An umbilical is also used to transmit the control fluid and electric current necessary to control the functions of the subsea production and safety equipments. It can be either a complete manifold tree, it can be valves, can be manifolds, etc. So, umbilical can be used actually a system which can transmit the fluid, or it can be a cable which conducts electric current, which is required to control the functions of the production systems. Dedicated tubes, essentially they are circular in diameter and shape. Dedicated tubes in the umbilical actually are used to monitor the pressure and injection fluids. As we discussed in the previous lecture, sometimes the well may require to be recovered by artificial recovery or enhanced recovery techniques. In such cases, dedicated tubes can be used in an umbilical to monitor the pressure inside the well or to inject the fluids. Sometimes, for example, a chemical like methanol can be injected to the well for faster recovery. These umbilicals basically run from the host facility to the critical areas within the subsea production equipment systems. Ladies and gentlemen, now the picture what you see shows the layout of consisting of umbilicals and jumpers. See here, this is actually my production jumper which you see here. There is an hydraulic jumper which is connected to my production jumper, followed by which is a separate line which I have what I call electrical jumper umbilical. Now, as I said, to recover the wells you can have water injection into the well, because to enhance the oil recovery sometimes injection into the well may be required. So, you can also have what we call a test production line. A test production line can also be there, and sometimes, as I said, umbilicals can be even electrical conductors, which is shown here. So, umbilical is nothing but a tubing or a piping which connects my host system to my subsea system production units. Electrical conductors which are used to transmit power to operate the subsea electronic devices can also be housed in an umbilical. The dimensions of an umbilical typically range from 200 millimeters in diameter. The umbilical will include multiple tubings normally ranging from diameter of 25 mm. The number of tubes which are used in umbilical, because as I said, umbilical is a combination of multiple tubings. The number of tubes which are used in an umbilical actually depends on the complexity of the production system which you are using. The more complexity the production systems are, you may require, for example, water injection, you may require oil injection, sometimes people do carbon sequestration as well. So, you need more number of lines or pipings or casings to do this. So, in that case the number of tubes housed in an umbilical will be much more. So, the number of tubes in an umbilical actually depends on the complexity of a production system. However, the size of these tubings are generally limited to 1 inch in diameter or otherwise 25 millimeters. On the whole casing or the piping will be of a diameter of about 200 millimeters. So, approximately in a group of an umbilical there can be about 6 to 8 tubes housed in a single umbilical. Now, the length of the umbilical actually is defined by the spacing of the subsea components. As I said, umbilical is a piping or a casing which is connecting the host system to my subsea production system. Therefore, the length of this umbilical actually depends on the spacing of your subsea components. Of course, it also depends on the distance where these components are located from the fundamental host facility. The host facility may not be always located near the place where the subsea systems are located or exactly vertically above the subsea systems, because subsea systems can be as in deeper waters where the host facility may not be necessarily located in the same depth as that of the subsea systems. Remember, subsea systems are production systems which are used where the conventional fixed type platforms cannot be installed. Let us talk about the host facility. The host facility can be any one of the various types of platforms which we have discussed in the previous lectures. These platforms are essentially used for developing hydrocarbon fields, which include fixed jacket type platforms. We have discussed about this in detail. The fixed type platforms can be of 2 gravity base as well as steel jacket structures. You can also have compliant structures like tension leg platforms. You can also have spars as your host facility. You can also have floating production systems, which we briefly call as FPS as your host facility. or you can also have what is called FPSO. Ladies and gentlemen, the O in the abbreviation stands for offloading systems. We discussed different types of offloading system in detail in the last lecture. The type of host which is recommended for a subsea system depends on many parameters. The host can be of any one of these platform types which we discussed in the last slide. However, how do you select which type of host you have got to use for what kind of subsea system? What are those factors based on which the host will be selected? You can guess, because now we have enough idea about the different types of host systems that are used for offshore production and drilling. So, obviously, as you correctly say, water depth will be one of the primary criteria to select your host. The type of field development, marginal, etc., will also tell you what type of host you must go for. It also depends on how much amount of oil reserve you have in that specific base, and of course, fundamentally how far is a subsea system from the host, what we call distance from the infrastructure. Above all, most importantly, the type of host system essentially is governed by the economic considerations. As you said, as you can clearly understood from the previous lectures, it is very clear that all types of platforms are not similar. They are categorically based on what is the type of water depth. Obviously, depending upon the geometric form and the structural configuration of these platforms, the cost of these platforms, installation, towing, decommissioning, etc., keeps on varying fundamentally in a very wide range. Therefore, it depends on what is your economic consideration when you design or select your host system. So, the host selection depends on the fundamental depth of water, the type of the field, the reserve base, the distance from where you are going to hold the host with respect to the subsea production system, and largely and majority wise it depends on what are your economic considerations. Let us talk about another important unit what we have in the subsea production system, which is a termination unit. Termination unit is a component of a subsea equipment essentially used to facilitate the interface between the umbilical or a pipeline or a flow line with the subsea equipment. See, obviously, you cannot directly connect a cable or an umbilical or a piping or a casing or a pipeline or a flow line. Ladies and gentlemen, I want to understand clearly the difference between the pipeline and the flow line. Pipeline is spread for a larger area, flow line is within the manifold or within the premises of the platform. So, when you are trying to connect either an umbilical or a pipeline or a flow line to a subsea equipment system, you need a piece which is called as a Taylor end piece, which will connect, which will fix these components of the subsea system to that of the subsea equipment. So, that Taylor piece or the end piece is what we call termination unit. The termination unit has many analogous names given in the literature. Sometimes people call them as pipeline end manifold, people address them as umbilical termination assembly, people also call them as electrical distribution structure, sometimes people address this as flow line lay down sleds. Remember, ladies and gentlemen, few slides down the line we saw a photograph where the flow line lay down sled was shown to you, which is connected as a termination unit to that of an subsea equipment system. So, the name only differs, but the function is a termination unit is actually a Taylor piece or a end piece which connects the umbilical or a pipeline or a flow line to that of the subsea equipment in general. It can also be used for electric or hydraulic control applications. That is also possible. You can use a termination unit for electric or hydraulic control applications. It is equipped with an installation arm to brace it during the lowering process, because you have got to fundamentally do this installation of termination unit very carefully, because the termination unit is one of the vital piece which connects the end of these lines to that of the subsea equipment. So, it comes with a bracing installation arm to brace it or to tie it up very carefully, then lay it down in the while during the lowering process. It is positioned near the subsea manifold. Usually the location of a termination unit, as the name suggests, it is as close as possible to my subsea manifold, production trees, flow line and umbilical collections on various subsea equipments. Alternatively, it is also incorporated in the design of manifolds and templates itself. Let us talk about another important component of a subsea system, which is production risers. The production riser is that portion of a flow line. You must understand what do you mean by a flow line. It is different from a pipeline. The production riser is a part of the flow line that is located between the host facility and the seabed adjacent to the host. Host facility can be any one of the type of platforms which we have learned by this time. Seabed adjacent to the host is the location between which the production riser will be located. The facility dimensions of these risers range from 3 inches to 12 inches, mostly circular in shape. Therefore, these are diameters of the production risers. The length of the riser is actually defined by the water depth and the riser configuration, which will be either vertical or variety of wave forms have been used as P lay, X lay, etc. So, the length is defined by the water depth where you are doing the production or drilling, and the riser configuration what you are planning to use for the production riser. The risers can be again alternatively of two types. You can have a flexible riser, you can have a rigid risers as well. They can be contained within the area of the fixed platform or the floating facility, or they can also run on the sea floor as well as run partially in the water column also. So, remember ladies and gentlemen, analysis and design of production risers is one of the most complicated tasks what you do in the analysis of offshore structural design, because they will be subjected to different kinds of environmental forces and they are as complex as that of the platforms themselves. So, production risers can be confined within the platform area, it can be also run all along the sea floor, or as well as they can run partially in the water column as well. So, you have to design these risers for all possible wave loads, current loads, seas cover bed forces, earthquake forces, settlement forces, etc., because pipeline or production risers are very long in length compared to the diameter. So, they have what is called a slenderness ratio problem in their design. These are different layouts of the risers what you see here. I can have a riser which is freely hanging from the host facility, can also have a layout called lazy S. This layout is typically named as a lazy S. You may wonder, how do you hold this riser vertically up over this point? I use a buoy here, the buoy will start floating at this location, can connect it here, they use a what we call as a pipe tray to connect one end of the production riser, and I call this layout of geometry as lazy S layout. I can also have what is called a steep S layout, where I will do the same methodology, then hold it down to the riser base. I can also use what we call as a lazy wave form, which is actually attained by distributed buoyancy, or I can also have what is called a steep wave form of these risers. So, the pictures what you see here are different types of layout of risers which have been used in the literature. The other component what we see in the subsea system is what we call as a template. What is a template? Template is a fabricated structure that houses the subsea equipment. The subsea equipment is housed on a fabricated structure, we call that by a specific name called template. Template can be of any shape, but typically people use commonly rectangular type templates. The dimensions of the template vary from 10 to 150 feet in length and 10 to 70 feet in width and 5 to 30 feet high. Templates generally accommodate multiple trees in tight clusters, manifolds, pigging equipment. Pigging equipment is used when you got the production risers choked because of some flow problems. Termination units, we have already seen couple of examples of different kinds of termination units which are put at the end piece with that of the pipes and the manifolds, and the chemical treatment equipments. Chemical treatment equipments are generally required you want to perform what we call injection of wells for improving the recovery or what we call enhanced oil recovery templates. So, template can accommodate multiple trees in tight clusters, it can contain manifolds, pigging equipments, termination units and chemical treatment equipment. So, the assembly of entire thing of this dimension is what we call as a template, as a fabricated structure, which is assigned as the name template in offshore engineering. You can see a typical figure of a template which contains umbilicals of given different color. This can be either electrical conduits, can be even pipes, can also have what we call pipelines which are given in different color. You have center hub which connects the host manifold module to the other different facility. The other figure shows how the subsea tree is connected to the hub using what we call a flow line jumper. Then the question comes in mind is, what are jumpers? Jumpers are pipe spools typically ranging up to 0.5 meter in diameter and 45 meter in length and are actually used to connect various subsea components as you saw in the previous picture. They are beneficial when tying in satellite wells through connections of small diameter pipes which are used for production. The diameter can vary from 3 to 6 inches, well testing lines can vary from 3 to 6 inches, hydraulic fluids can vary with a diameter of 1 inch and the chemical service lines can vary to a diameter of 1 inch to that of the manifold. Offset distance between the components. What are the components of subsea? You can say trees, you can say flow lines, you can say manifolds, etc. The offset distance between these components actually govern the jumper length and the design characteristics of the jumpers. Flexible jumpers are one of the variety of jumpers which are provided. They give high versatility unlike rigid jumper systems, which limits the space and handling capacity. So, flexible jumper systems are preferred in deep water offshore engineering where unlike rigid jumper systems they do not limit the space and handling capability. Now, the picture shows what are the different types of jumpers. You see here, this is a manifold, these are well jumpers what you see in the black color here. What I am calling this as a tree, these are all the flying leads which are connecting the tree each other. You can see the blue line here can be a piping or a casing, I call this as electrical umbilical. Now, this carries fluid, I call this as hydraulic umbilical. These are all flow lines, these are all flow line jumpers and so on. So, you must now understand a typical layout of a subsea system. What are the important components in a subsea system, like a manifold, like a flow line, like a pipeline, jumper, what are trees, what are umbilicals, etc. after understanding this lecture. Thank you very much.